So what we're going to go over is we're going to go over perfect squares and square roots. We're going to learn a bunch of like numbers, which you don't have to like memorize per se, but you should definitely get so comfortable with them that you know them when you look at them, like you identify them really quickly. These numbers will be very beneficial to have learned by next year because you will use these perfect square numbers all the time in Math 10C, which is the class that most of you are going to be trying to get into next year. To start it off, we're just going to create something called a perfect square chart. So a perfect square chart is when you take two numbers and you multiply them against themselves. So for instance, like you take number 1 and you go 1 times 1, also known as 1 squared. Right? We've learned about exponents, so it kind of makes sense. We're going to create this chart. I'll create it with you. The higher ones I don't have memorized, so we'll have to use our calculators. But if we do 1 times 1, it gives you 1.
Wait, did you start with it?
If you, yeah. It did the 3, 2, 1 and everything. If you do, If you do 2 times 2, it gets you 4. If you do 3 times 3, 9.
What?
Remember that we're multiplying, right? So it's 3 times 3 to get 3 squared. 4 times 4, 4 squared is 16. You should be filling out this chart with me because you're going to need this chart. 5 times 5 is 5 squared. That equals 25. 6 times 6 is 36. 7 times 7 is 7 squared, which is 49. 8 times 8, 8 squared is 64. 9 times 9 is 81. 10 times 10 is 100. I'll let you just copy those down quick, and then we'll do the other side. If you look at the right side, it's all there on the board. 11 times 11, 11 squared is 121. 12 times 12, 12 squared, 144. 13 times 13, 13 squared is 169. 14 squared, I don't remember that one. I saw you writing them down. Can I still get calculator? 196 is perfect, and then I won't have to ask you every time.
I know it.
15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Okay. You should have all those written down. Like I said, you don't have to have them memorized, but you should like be able to kind of identify the first 10 for sure. So those are like the more common ones. It's pretty rare we go past 10 after this class. Like in this Math 9, we'll do past 10. But in grade 10, when you're using these numbers and utilizing them all the time, it's typically just the first 10 you need to know. So these numbers that we just created, these numbers, I'll circle them in red. They're perfect square numbers. That's also called your perfect square chart, right? And that's also something you might hear it referred to as. These are also perfect square numbers. I just didn't want to write it out twice. Meaning that they came from a whole number squared to create these numbers. That's all it means, right? And if you have the first 10 memorized, that'd be fantastic. Awesome. Sliding down. the square of an even integer is always going to be even. So if you have a number that's even and you square it, it'll always create an even number. So if you look up at your chart, like 4 squared was 16, 8 squared is 64. It was even numbers are creating even numbers. When you had odd numbers and you were squaring them, if you look up at your chart, it was always creating odd perfect square numbers. Right? 3 squared was 9, 5 squared is 25, and it's always creating odd numbers. So the square of an odd integer is an odd number. The reason why square numbers and perfect square numbers might be useful is because you can represent them really well with area and with perimeter, because perfect square numbers can also represent perfect square objects. If you look here, they have two beautiful pictures for you. They have this guy, which is a 5 by 5 grid, right? 5 by 5 meaning that there's 1, 2, 3, 4, 5 blocks, and 1, 2, 3, 4, 5 blocks. When you have blocks like that, where you have like 5 across one and 5 across the other, you can figure out the area by just multiplying the two sides. Right? So if you look at this first picture, you have 5 across the left, 5 across the top. You could represent the area by doing length times width, right? You've seen that before. 5 times 5 is 5 squared, gives you 25 blocks. So it's a quick way to calculate your inside on a square. The square right beside it is just undoing that. So if you had a square and you knew the area of that square, this guy right here, the area is 25. Then I could figure out the side lengths by going backwards. The opposite of squaring something is square rooting something. Hopefully that's a symbol you've seen before. So this right here, that's a square rooting symbol. I meant to do it in red so you could see it better. This right here, square rooting symbol. You seen that? Yeah, you can definitely step closer so you can see it. If you square root something, it's like breaking it apart into its two things that are the exact same. So the square root of 25 breaks up to be 5 because 5 times 5 would give me 25. It's literally the opposite of squaring something. It's taking a number, breaking it into a number that times itself would equal the area. Awesome. We got a bunch of pictures here where we're going to see how you could go from area to side length of something. This first block has an area of 49. There's 49 blocks in there. It does say it. It's kind of hard to read on your sheet, but it says area equals 49 square units. They got the area by doing 7 times 7, which if you look, they tell you that there's 7 units on each side. To figure out area, length squared, 7 times 7. That equals 49. You could go backwards. So if they only told you the area and you said, okay, the area is 49 and you want to go backwards, you could figure out the length by square rooting the area, which would give me 7. That means I can go forwards or backwards. Know the sides, create the area. Know the area, find the sides. The second one is a little less filled in for you. So if you look, you have 4 units here. If I wanted to figure out the area, that means I have 4 by 4. We know that if you take your length, I'm just going to represent it with an L, and you square it, it'll equal your area. That's the idea. Take your length, square it, figure out your area. For us, that means 4 times 4 is 16. My area is 16. If you knew the area, you could go backwards. So the square root of your area equals your length. That means 49 squared would give me 4 as my side length. We can do the next 2 as well. Again, I'm not going to put the L in the area this time. I'm going to put the actual numbers. My length is 8. So if I went 8 and I squared it, that would give me 64, which means the area of that square is 64. If you worked backwards, that means the square root of 64 would equal 8. And that would be your side length. You could do one more. So there's one there. It's got side length 11. So if I know my length is 11 and I want to figure out the area, then I would square it. The square of my area or my side length is 121, which gives me my area of 121. Again, you could work it backwards. If you have an area of 121 and you square root it, that would give me 11, meaning that the side length is 11 units big. Okay? It's just working backwards. It seems kind of trivial, but it is something that you're going to need to remember for next year when it starts coming up and you're going to be like, I've never seen this before, and you have seen it before. Right? You can square root area to get length. It's the opposite of squaring. You can also square root decimals and fractions. I'll zoom in a little bit so you can see a little bit better. The way you square something, we learned this last week sometime. If you have a fraction squared, we learned that you take the square and it comes in the brackets. Right? Remember that? And it becomes 3 squared divided by 5 squared. Right? We call that a power of a power law. Like the power comes into the brackets and it goes to both things. It's been a while, but it was a couple weeks ago. That means if you had 3 divided by 5 squared, it actually turns into 3 squared over 5 squared, which is 9 over 25. You can undo fractions the same way. So if you wanted to square root a fraction, it actually is the same thing as saying the square root of 9 divided by the square root of 25, which would become 3 over 5. So square rooting works the same way as squaring. When fractions, you can just break it up one into the other. Awesome. With decimals, it's a little bit trickier. Honestly, if I were you and I had decimal and I was trying to square it, I'd just do it on my calculator. Actually, I do that with almost all these questions. With the fractions, your calculator doesn't do it as well, but with decimals, your calculator does it perfectly. So if you had 1.2 squared, if you put in your calculator, it equals 1.44. Another way you could do it, which you won't have to really remember, but it's a good little trick if you want to do mental math, is instead of doing 1.2 squared, you move the decimal over and you imagine that as 12 squared. 12 squared is 144. Then you just move the decimal back to get 1.44. So if you're looking to do mental math, which is always a good skill to have, that's how you could square decimals. And you just move the decimal so that you have a nice whole number, square it in your brain, move the decimal back. You could also go the opposite way, so you could square root something, like this guy right here. The square root of 144 would give me 1.2. Same way it just did the other way around. Cool. The concept you should be trying to get here is that you can undo squaring by square rooting. Yeah. Yeah, same idea. So this one's a little bit trickier when you're square rooting it because you would want to move the decimal like twice. So you're really looking at like yourself 144. 144 becomes 12, and then you just move the decimal back over. Except the decimal placement's a little bit trickier when you're going the other way because it kind of disappears on you. And then it goes from 3 digits to 2, so it kind of loses people. But yeah, you just move the decimal 1 back over. Cool. We have an example here with a square that's shaded in. So it says, express the area of the shaded region compared to the entire square as a fraction and as a decimal. If you look at this fraction shaded square thing, if you count out the sides, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares total. How many of them are shaded? 9, right? 9 is shaded, so that means 9 out of 10 are shaded. They want to know the area of the square that's shaded relative to not shaded. That's why I'm saying 9 out of 10 are shaded in. If you want to do area, it's length times width. So I have 9 out of 10 times 9 out of 10. That's the same thing as saying 9 out of 10 squared. And that's how you calculate area, length squared. If you put that in your calculator, it'll give you a decimal. You don't want decimals. We want to stay with fractions. So we use our exponent law where the 2 will come in, and it'll become 81 over 100. That represents the area of the shaded region. relative to the unshaded region, the whole box. Take side length, square it, gives you area. Not too crazy of a concept. If you wanted to undo that, so say they give you this picture and they're like, okay, looking at that, there's 81 shaded blocks out of 100 possible blocks. That's the area. And they said, what's the side length of that area? Then you would want to square root the whole thing, because square rooting area gives you length. When you're square rooting, you can break that up into two separate things. So square root 81 over square root 100. In your calculator, you could figure out the square root of 81 is 9, and the square root of 100 is 10. You could also figure that out by remembering your perfect square chart. I mean, like 81 was on my perfect square chart, right? Look. 81 is on my perfect square chart right here. That means the square root of 81 must be 9. That's how I can undo it. Same with 10. 100 is on there. Square root of 100 is 10. It's going backwards. Yeah. No, you're good? Okay. Wicked. I'll do one of these. Actually, I'll do 3, and then you'll do 3. So we'll start off with area. Then we're going to try to find area as a product. So that means break it into its two pieces. And then we're going to do side length. First question says area is 36. I want to break that up into a product. Product means multiplication. So something times something would equal 36. In this case, it would be 6 times 6 equals 36. If you weren't sure how to do that, then what you want to do is square root your area, and it'll tell you the numbers that should go here and here. It'll also tell you what your side length is, because the square root of area is your side length. So in our case, square root of area is 6. If they gave you the area as a product, that means they gave you the two lengths, I could figure out that this is 64. The side length is 8. Right? They're saying 8 times 8 is your box. One side must be 8. The product of those sides would be 64. That's the area. The third one, they've given me the side length. So if my side length is 5 and I want to write area as a product, that means it turns into 5 times 5. If I want to figure out the area, I just square the length or do 5 times 5 in my calculator, which is 25. Yeah.
For the decimal, or not the decimal, the fractional.
Yeah.
The 3, 4, how would you do that?
So if you went, you're skipping ahead to this one right here?
Yeah.
Okay, so if you took that one, they're telling you the area as a product is 3 out of 4. That means one side length is 3 out of 4, right? That seems a little simple. That's one of your side lengths. If you want to figure out what the area is, then what you're doing is you're multiplying these things together. And when you're multiplying fractions together, you multiply the top number with the top number, bottom number with the bottom number. So mathematically, it kind of looks like this. 3 times 3 divided by 4 times 4. And that's how fractions multiply together to become 9 over 16. And that was, again, a useful skill for our exponents last unit or last week, is that you want to multiply top numbers together, multiply bottom numbers together. And that's how you multiply fractions. Looking at the one above, they've given you the area. If you want to break the area up into the length times length, we square root the area. When you square root a fraction, it breaks up into two separate square roots. So you have square root 49 divided by square root 100. The square root of 49 is 7. The square root of 100 is 10. So this breaks up to be 7 and 10 as your two fractions. If you're not sure how to do that, and you're like, I have no idea how the square root of 49 became 7, look at your perfect square chart and find 49. 49 is right here. If I unsquare 49, it gives me this, 7 times 7. That means the square root of 49 is 7. So down here, I'd have 7 out of 10 as my side length. The last example they gave you the side length. They said side length is 7 out of 9. They want you to write it as a product. So that means I'm going to write it as 7 out of 9 times 7 out of 9. And using our trick to multiply fractions, top numbers multiply together, bottom numbers multiply together. 7 times 7 is 49. 9 times 9 is 81. As a fraction, that's 49 over 81. And you should try to get comfortable leaving it as a fraction. Don't always just change to a decimal. Like, make that a fraction and get used to it. Especially since we are going to have to do mental math this year. Right? There's a part of the diploma with no calculator. So you're going to have to get used to it. We'll practice for it when it comes. We might as well start practicing now. All right. A couple word problems where this stuff might actually become useful. So you got a square picture. The square picture has an area of 169. They now ask you to find perimeter. Who remembers what the word perimeter means?
Around the outside.
Yeah, it's all the way around the outside. Like if you were to add it up, like if you were on a pathway, you'd be walking all the way around the outside of it. Right? So we would say it's this length plus this length plus this length plus this length. For me, perimeter equals length plus length plus length plus length. That's what perimeter is defined as. So for us to find the perimeter, we have to find what the side length is. The only thing they've told us is that it has an area of 169. Our job is to go from area to side length to perimeter. How can I turn area into length? Yeah.
By square root.
By square rooting it. Right? The rule is that the square root of area will tell you your length. So for us, if the area is 169, that means the square root of 169 will tell me my length, which happens to be 13. If one length equals 13, now I can figure out perimeter by going 13 plus 13 plus 13 plus 13 to get an answer of 52. So a picture that had an area of 169 had a perimeter of 52. The way we got there, we took area, we square rooted it to get length, we added all 4 lengths to get perimeter. That's kind of a trippy question because it's got a lot of steps to it. Does anyone have any question over like where a number came from, how I knew to square root, or how I knew what numbers went where? All right, let's go the other way. So they've given us now a couple problems where they've told us the length. It says determine the area, so figure out what area equals, with a side length of 25 units. If you want area, then you want to do length squared. So for us, our area would equal 25 squared. That's not one I would expect you to have memorized, but you could definitely put in your calculator. 25 squared equals, anybody do it?
Yeah. 625.
625, thank you. I wasn't even going to be close. So the area of that square would be 625 units. Try B on your own. So they're giving you length, asking for area. Okay, so they gave you length. We know we want area. Area equals length squared. So what I should have done is taken my length and squared it. If you put that in your calculator, it's going to be a big number. 1843? 49, thank you. The area of that thing would be 1,849. It's big. Awesome. Example 6 is just writing out what we've been saying. Sometimes it's good to read it and see the words for it. So it's just a sentence. It says, the square of 32 is 1,024. Mathematically, how I would write that sentence is I would say 32 squared equals 1,024. That's what that sentence means when they say the square of something. It means take that number squared. The second question, or the actual question, says, what is the square root of 1,024? Mathematically, they're saying, what is the square root, that's the square root symbol, of 1,024? We know that I can look over here and realize, 1,024 came from squaring 32. That means the square root of 1,024 must equal 32. Right? It's just undoing a square. Number 7, the square root of a perfect square is 11. What is the perfect square? So again, if we're reading this, the square root of a perfect square is 11. The square root of a perfect square I don't know what the perfect square is. When I don't know something in math, I call it x. So mathematically right now, I've put the square root of something, of a perfect square. Is in math means equals 11. That's how you could take that sentence and turn it into a math question. Right? That's what they're asking you. The square root of something equals 11. Then the question is, what is the perfect square? What is that number? Yeah. 121. Perfect. So if you wanted to know, it's just the opposite of something, right? If I want to figure out what's under here, and I square rooted something to get 11, I could go backwards and say, well, then 11 squared must equal x. It's opposite. And if you do that, then you do get 121, which is what Mackay said. Cool. Number 8. What is or are the perfect squares between 9,000 and 1,000? We're actually in a,
It's 900.
do you know it? Oh, perfect. So 900, you're right. 900 is a perfect square. Are there more perfect squares in between 900 and 1,000? 961 is one of them? Cool. What is that equal? Like what squared equal 961? 31 squared? Cool. That equaled 961? Awesome. What was 900 squared? You had that. Was it 30? Okay, because 30 squared is 900 and 31 squared is 961, I know there's no other perfect squares in between 900 and 961. Because there's no numbers between 30 and 31. That makes sense? Right? 900, 961 are my perfect squares. There's nothing in between because there's nothing in between 30 and 31. My next possible one would be 32. So if you did 32 squared, what do you get?
1,024.
Which is beyond 1,000. So that means the only perfect square numbers are 900 and 961. Below is a big perfect square chart. First 400. We're going to try to shade in all the numbers that are perfect squares. To figure out all the perfect squares, you could just run through your calculator, right? Be like 1 squared equals 2 squared equals. And I'll help you while we shade it in. So 1 squared equals 1. So the very first one you can shade in is number 1. The next perfect square would be 2 squared. 2 squared is 4. The next perfect square would be 3 squared, which is 9. Next perfect square would be 4 squared. 4 squared is 16. I want you to take a moment and try to shade all the way up to 400 all the perfect squares. You should have, I believe, 20 of them shaded in. So I'll let you try to find them all. You might have even had it on a page earlier. Okay, I have all the ones shaded in up there. Those are the first 20. And you'll notice that there's bigger and bigger gaps. And so this kind of gives a picture of that. If you look at the first 2, there are only 2 numbers in between them. Then there's 4 numbers in between them. Then there's 6 numbers in between them. And the gap just keeps getting bigger and bigger in between perfect squares. And that's because the numbers you're squaring keep getting bigger and bigger and bigger. And there is no decimals in between. So when I go from 4 squared to 5 squared, I would never call like 4.5 squared a perfect square number. None of these things in here are perfect square numbers. So you'll just notice, and it's a good little visual, that there's big gaps. And as you get further on, you can see the gaps are getting bigger and bigger and bigger. The gap is a whole row, 3 more. The last one is almost 2 full rows. Right? So it's kind of a visual that there's big gaps in between perfect square numbers the bigger you get. Awesome.